Hello, everybody. We're going to continue almost immediately where we dropped off. We're going to introduce a new rule, sometimes referred to as the quotient rule. Knowing quotient meaning something that has been the result of a division. So when we're going to talk about a function that's built from the division of two other functions. This goes hand in hand. Last class we talked about the product rule. So quick review of the equations that we've seen so far, or the rules. We have the definition. Rule 0, reminder, everything that we talk about today ultimately comes from this rule. And we're not going to say that this is not true. We're just not going to always, in every single case, take the longest route. If we can ever find a pattern that speeds this up, we would much rather do that. So the rules that we've talked about so far, we have the sum and the difference rule. We have the constant multiplication rule. We have the power rule, reminder. More things are powers than you really think about. As a reminder, you can always change these radicals and these reciprocals into powers, so keep that in mind. Last lecture, we talked about the exponential rule. We're going to get way more involved in this in a later lecture, but for right now, this will serve its purpose. And we also have the so-called product rule, which we talked about last one. It's important to note that it's more complicated than addition and subtraction. Now, unfortunately, the quotient rule is also going to be a little more difficult than just the product rule. So let's say we let f of x be what I call p of x and q of x, standing in for numerator and denominator. The quotient rule can be written like this. The derivative of p divided by q is q times p prime minus, please remember this minus, q prime times p. Then we put that entire expression divided by q squared. I like to write it down right here. I think this is worth thinking about in your head. And this is honestly what I think about in my head every time I do the quotient rule. The bottom times the derivative of the top minus the derivative of the bottom times the top, all divided by the bottom squared. Please note, if you rewrote the product rule backwards, you actually end up with the same thing, because these multiplication and addition don't really have an order. Unfortunately, subtraction and division definitely have an order. So this is a really important one to keep track of. Okay? So, not a proof, because I think it's a little bit too general, but I want to take a look at f of x equals x, there's my p, x plus 6, there's my q, and I did the by hand definition. And I get this expression right here. And the whole point is that I want to not use these rules. I want to be able to find these much more quickly and much more generally than maybe I had been able to previously. Okay? So, how exactly am I going to start finding some of these? Well, one of the ways that you can do it is exactly what I did when we were talking about the product rule. Is I like to make this little table. I define a p as a numerator, a q as a denominator. Here's p prime. Apologies, I don't know why that's there. There's p prime. There's q prime. And I just use the definition, plug in, and I do simplify. And as a reminder, some questions will let you get away with not simplifying. But in general, it's always good to simplify because it will make doing anything later a little bit easier. Okay, so that was just for your personal collection. Let's do some homework questions. And unfortunately, the only way to get really, really good at this is to do a lot of these. So, we'll make our table. Here's our y, and we want to find the derivative of y, aka y prime, or dy over dx. Here's our p and our p prime. I might as well do it in blue. Here's q, and here is q prime. Okay, so p is 3x squared minus 5x. That makes p, again, power rule. I'll bring down the 2, 6x. Bring down the 1, minus 5 times x to the 0. But x to the 0 is 1. There's p and p prime. To find q, 5x plus 6, and once again, bring down the 1. We get 5x to the 0. There's also an x to the 0 here. We bring that down. But, as again, x to the 0 is 1, and anything times 0 equals 0. So there are our pieces. Let's put them together. So reminder, it's q times p prime minus q prime times p all over q squared. Now, on the specific example that I want to take a look at, this, I need to point out, is not simplified. So we do need to do some simplification. How are we going to do that? Well, the first thing we're going to do is we're going to FOIL out this term. We'll say it's 30x squared minus 25x. Let me scooch over a smidge to grab myself some more room. So 5x times 5 is negative 25. 6 times 6x is plus 36x. And 6 times negative 5 minus 30. There's the blue. Let's use another color. We also are going to distribute out this. And as a reminder, we're distributing out the negative 5. Right? So negative 5 times 3x will give me negative 15x squared. And negative 5 times negative 5x will give me plus 25x. Don't forget, we'll take that whole thing and we'll divide by whatever 5x plus 6 squared is. So we can actually rewrite that as 5x plus 6. Oh, sorry. I would much rather have a different color. It's going to be 5x plus 6 times 5x plus 6. We'll also multiply that out. Let's do some gathering. So we have 30x squared minus 15 of them, leaving up with 15x squared. Excuse me. Now, be very careful. We have minus 25x plus 25x canceling out, leaving us with the 36x. And then we have a minus 30. Now, keep in mind this is 5x plus 6 times 5x plus 6. Now, why haven't I expanded out the bottom? Well, I want to wait real quick, and I actually want to try to maybe factor this. It might factor quite nicely. So the first thing I want to point out, that's divisible by 3, that's divisible by 3, and that's divisible by 3. So I can pull out a 3 from each of them, and we'll get 5x squared plus, I think that's 12x minus 10, all divided by 5x plus 6 times 5x plus 6. Can I factor this any further? You know, there's lots of ways that you can check this. You can take a look at, 5x times x. And we have to think about, we want things that multiply to equal 10, but add to equal 12. So as a reminder, that's 1 and 10, or 2 and 5. So one of these is going to get multiplied by 5. 15 minus 10 minus 5. I don't think there's any good simplification. I would be okay with something like this. And so grabbing this specific homework question, if we try it, as a reminder, our answer was 3 times, this was 5x squared plus 12x minus 10, and we'll divide that by, sorry, I forgot, 5x plus 6 squared. Now, the reason you want to try to factor the top is you might get really, really lucky and there might be some shared factors. And by that, I do want to point out, It's lucky in the sense that it gets simpler, but sometimes it doesn't work. Now, there are lots of quote unquote simplified versions of this question. I'm not going to say that it has to be in this form. What I mean when I say to simplify something is specifically this step, where you expand it out, and any terms that have, we call this like terms, this term contains x squared and this term contains x squared. That's what simplification is. If you wrote down this answer, you would still be correct. However, if this factored nicely, let's say there was a 5x plus 6 somewhere in there, you would need to ultimately try to grab that in your term. Apologies for that weird pause. My computer screen decided to force an update, and I was unable to pause the recording in time. So we'll continue on. Let's do another, hopefully, really quick one. This is one that you're going to see a lot, where we have some exponential function as well as some sort of polynomial. And again, our goal is to define a p and q such that we can find those derivatives individually. P is e to the x, q is 9x squared plus 2. Let's choose colors maybe easier on the eyes. P prime, derivative of e to the x is e to the x. Q prime, bring down the 2, 18x plus 0. And again, we always omit the 0. Derivative of constant doesn't exist. So, as a reminder, what does that make g prime of x? Remember, bottom times the derivative of the top minus the derivative of the bottom times the top, all divided by the bottom squared. And unfortunately, there really is no simplification that I can do. If you would like to do a simplification, or if you're ever asked to do a simplification, there is one thing that we can do. Notice both of these terms have an e to the x. We can actually pull out that e to the x as 9x squared minus 18x plus 2 all over 9x squared plus 2 quantity squared. And that will suffice for our answer. It's very difficult in general to simplify terms that are both polynomial and exponential. Not impossible, but very rarely does it actually happen. And if it does, usually there's some inherent structure that makes it quite nice. So just to kind of prove to you, we did get that one right. All right, one last one, because I think I'm having some issues with my, actually with my screen right now. I'll investigate that further. This one, I'll give you a quick snapshot. This is coming from question, I think this is question number 14. It says, given that f of 5 is 1, f prime of 5 is 6, g of 5 is 4, and g prime of 5 is 2, it wants us to find the derivative of the product and the quotient of those two graphs. So, as a reminder, just in case you weren't able to get those down, f of 5 is 1, f prime of 5 is 6, g of 5 is 4, g prime of 5 is 2. So, as a reminder, what does the product and what does the quotient tell us about f times g and f divided by g evaluated at 5? Well, the product rule is f prime of 5 times g of 5 plus f of 5 times g prime of 5. That's just using the product rule. Versus the quotient rule, forgot the t, is going to be the bottom original times the derivative of the top minus the derivative of the bottom times the original top divided, and this is where students forget, by the original bottom squared. Let's plug in. So f prime of 5, this is going to be 1 times, apologies, this is going to be 6 times 4 plus 1 times 2. Been a while since I've done mental math like this. I think that's 24 plus 2 is 26. I'll be honest, I should use a calculator for this. I recognize that. That's how I got into trouble last week. Turns out I was able to get it. What about this one down here? Well, again, we're just plugging in the right things. We have g of 5 times f prime of 5 minus g prime of 5 times f of 5. You're going to notice a very similar structure here. And what else do we divide by? G of 5 squared. So, once again, I think it's 24 now minus 2 divided by 4 squared is 16. This is 22 over 16. One more, I think it's 11 over 8. And again, if you want to use you should use a calculator for this. I am just trying to, I don't want you guys to have to wait for me to take these, do these calculations on a calculator. So, there we go. Okay, now, it's important that we recognize that the quotient rule and the product rule are, they're just helping us find these derivatives. But ultimately, they do rely on the definition of the derivative. We should never forget that. One last thing I want to leave you with. There's a question towards the very end of section 3.4, which has to find this derivative. And I just want to really point it out. Make sure you understand this has two things that make it differently. First of all, there's an extra x. So we actually have to use the product rule to find the derivative of the top. And also, weirdly, they switch what I would call, typically, it's f of x over g of x. They wanted to call it g of x over f of x, which, they just want to make sure that you're paying attention. So if we kind of work this one throughout, and I'm going to do part of it, what is our p? Well, it's x times g of x. And what's our q? Well, that's f of x. Now, q prime is easy. That's just f prime. But what is p prime? We need to use a product rule. And as a reminder, we can go first and second. It's the derivative of the first times the second plus the first times the derivative of the second. Then we have to use this entire thing as p prime inside of, inside of a quotient rule, which, once again, bottom times the derivative of the top minus the derivative of the bottom times the top all over the bottom squared. Good luck with these derivatives. If you have specific homework questions you want to send me or anything that you think will benefit you, please don't hesitate to let me know. And I'll see you all in the next video, which is the last video for I think is the last video, new stuff before the week is over. So congratulations, we're going through it. As always, if you need anything, let me know, and I'll see you all towards the end. Bye-bye.